Good morning again, and welcome to our 2022 Multifamily New Construction Cost Effectiveness Analysis webinar. I challenge everybody to say that 3 times quickly. My name's Misty Bruceri, and I'm the coordinator for the REACH Codes program, which is part of the Utility Statewide Codes and Standards program. I am here today with Aaliyah German from Frontier Energy. Aaliyah is our residential lead on our technical team and is going to present the results of our analysis today. So thank you for joining us. We do appreciate it and know that you're all busy, so we appreciate you taking the time. Okay. So first, before we begin, I want to say that we are recording this session. So please note that. And also, both the recording and the presentation will be available on the localenergycodes.com website after the session. So I'm going to get things started with a brief introduction and overview of the program and the high-level objectives of the analyses. And then I'm going to go ahead and turn things over to Aaliyah to provide a detailed review of the study analysis, the analysis itself, the methodology, the assumptions, rationale, and all the results that we have so far. Lastly, I'll be back at the end to provide just a brief summary of some of the ordinance options that are supported by the analysis. Okay. So as I noted, the REACH Codes program is part of our statewide codes and standards program. And our main objective is to facilitate the adoption of REACH codes to help local jurisdictions do what it is you'd like to do and accomplish your policy goals. As part of that work, one of the main things that we provide is a cost effectiveness analysis statewide that is a tool that can help you support informed decision making and to support your policy decisions and the goals that you'd like to achieve. We also provide draft model language. We work with several others in the field to do that. We develop several different types of resources and tools. We have checklists and other things like that. We also have a very complex tool, the Cost Effectiveness Explorer, which can help you develop the ordinance itself and look at the impacts and compare impacts of different policy choices. We provide technical support. We'll review model language, help you through any of the analyses, talk you through some of the results if you like, and of course communicate these study results to our stakeholders, which is what we'd like to do today. And lastly, we do publish a newsletter and also other resources featuring cities that are front runners, that are ahead of others and taking aggressive policy steps. Provide a lot of different services. Okay, so one of the main services that we provide is this cost effectiveness analysis. And as I've noted previously, the multifamily portion of the code has been completely restructured this cycle. And because of that, there have been a lot of major changes required to both the compliance software, all the documentation, and all the supporting materials. And so we have been working with the beta software. The technical team has been, they are one of the early users of the software. And so fortunately, unfortunately, it's hard to tell, but they often discover some of the oddities or anomalies. And so they have been doing that, and they've been working with the software developers to get some of these things taken care of. The results we have today were done in that beta version. We just got a new certified version a couple of weeks ago, and the team is updating those analyses now to get them current. We do anticipate that there will be some more changes to the software, but we just wanted to make sure that you're aware that there's a lot of things that are moving in parallel, okay? And so I want to make sure that also that you know that we're still working on the analysis, but we realize the timing and that many of you are beginning outreach, that you're starting to communicate with stakeholders about your plans, and so we felt like even though we still have some work to do on these results, that we really wanted to communicate with everybody the progress that we've made to date and what we see, how we think how things are going to play out here. Okay, so given that, I wanted to just note a couple things about the studies. The main purpose of these analyses is to meet a specific legal requirement that REACH codes need to fulfill, which is to identify a cost-effective and non-preempted package of measures that can support an ordinance. Because of that, we do the studies in a certain format that is intended to support a bunch of different requirements statewide, so that could be adopted anywhere in the state. We also provide the results in two different formats. One is what we call on bill, which is the individual utility customer's perspective of how these results play out. And the other is TDV, or time dependent valuation. And that is actually a code metric, but it reflects the cost of providing the energy. So energy that is either used or saved on peak is valued higher than energy used or saved off peak in that structure. Okay, and it just gives us a little bit more of a societal perspective in what it costs to provide that energy, including the externalities. Okay. The studies are based on Title 24, and they are consistent with Title 24, the Energy Code, Part 6. And we try to keep them conservative if we can. We're aware that it's much easier to make a project comply on paper than sometimes in real life, so we do keep our assumptions conservative in order to allow for a little bit of room for the variation in projects that actually get built. One thing I do want to point out to everybody is, again, our objective is to meet a legal requirement. So the study packages that we come up with are not an example of best design practices. One could design a building in a more efficient way with many different features. And they're also not a list of specific measures required. The measures that are in the study just make up the package that we have determined is one pathway. In practice, a builder or a project applicant, homeowner, can use any package of measures that they like to meet the requirements. Okay. Alrighty, just going to talk about these just a little bit before we dive in. I'm going to talk about the code compliance metrics because they've changed in this cycle. Multifamily metrics now are the same as non-residential metrics, and the structure is similar to the single-family metrics in that there are 3 separate metrics and projects have to meet each one of them independently. Okay, so the first metric is time-dependent valuation, which I talked about, and that has now been split into 2. That was our code compliance metric in the last cycle, or in the current cycle. I guess it feels like the past already in a REACH codes world, but it has been the metric for a while now. And it has been split into 2, similar to the single family metrics. And there is now an efficiency component and a total, a TDV total, which also includes the impacts of PV and storage. So you get efficiency, PV, and storage in there. And lastly, there's now a source energy use component. And that metric actually is a proxy for greenhouse gas emissions. In doing some analysis, the CEC discovered that hourly source energy tracks with greenhouse gas emissions very closely. And so this metric is a proxy for that. And so again, projects have to meet all 3 of these metrics independently. And so it's much like I said, much like single family, only there's no energy design rating, no EDR. But the metrics are function the same way. Okay. In doing this analysis over the years, we've discovered that if you require a compliance margin, which is a difference from the minimum required, basically, you could use it in percentages or in EDR points, but in this case, it's likely in percentages. That tends to work better than using absolute values by saying you have to meet a certain number. What winds up happening is that different projects have different absolute values, and so when you use a metric, you wind up requiring similar measures from all different projects. and instead of potentially having one project be a lot more stringent to meet the same goal. Okay, and in all cases, the efficiency, renewables, and load flexibility improve the cost effectiveness, as we've all known for many years, over just a standard minimally compliant building, whether all electric or mixed fuel. Okay, and with that, I will hand things over to Aaliyah to actually talk about the studies and the methodology that she used. Take it away, Aaliyah.
Great, thanks so much, Ms. D, and thanks again, everyone, for attending today. All right, so I'm Aaliyah German with Frontier Energy. I'm also joined today by Avni Goyal from TRC. TRC has been leading the energy modeling for this work, and so we have her and her team on the line to respond to any modeling specific inquiries. I'll talk a little bit about methodology of our work, give some background on relevant changes in the 2022 code. We won't go too much into that, and then provide a summary on the cost and measure details, and then we will look at results. So for those of you that are familiar with our other statewide REACH code studies, we generally are following a pretty consistent approach. For this analysis, it builds on the 2019 multifamily REACH code work, and also a lot of development that went on in the 2022 code cycle. There was the restructuring of all multifamily buildings, alignment across all multifamily building types, and we'll cover that a little bit later on. And then the multifamily all-electric case analysis, which looked at space heating and water heating electrification for the state code. The new 2022 prescriptive Title 24 code requirements are our starting point. We have a new software, which Misty alluded to, CBEC 2022, and we're using a beta version. There has already been a new version updated, and we will be updating the analysis. And similar to all of our residential analyses, the cost effectiveness is evaluated over a 30-year analysis period. As part of the 2022 code cycle, the Energy Commission adopted 4 new multifamily prototypes: a 2-story, a 3-story, a 5-story, and a 10-story. And as part of the work in the 2022 code cycle, there was some data that was collected that suggested that for new construction, the 3-story and the 5-story represent about 90% of new construction. So that's what we have focused on in this study. We are looking at evaluating these 2 prototypes. There's the 3-story, 36 unit, about 40,000 square feet. It's a slab on grade wood frame construction building. The HVAC systems are individual to each dwelling unit. Water heating is central. And there are some common area support spaces, laundry room, fitness center, leasing office corridor, but no true commercial spaces. The 5-story is 4 stories of residential over 1 story of retail on a concrete podium over a parking garage. It's also wood frame construction and also has individual HVAC systems and central water heating. The 2022 Title 24 code is our starting point. There's similar base case requirements across the 2 prototypes, but there are some nuanced differences. Heat pumps for space heating are now a prescriptive baseline in almost all cases. The 2 exceptions are climate zones 16 and 1. And this is one area where there is some differentiation between what has traditionally been termed low rise, 3 stories and below, and high rise, 4 stories and above. So in our 3-story prototype, we have a gas furnace in climate zone 16. And in the 5-story in 1 and 16, we have a dual fuel heat pump. So that is a heat pump that is used as a primary heating source. Instead of having an electric resistance backup heating source or no backup heating source, there still is gas within that system to provide backup heating. The base starting point for water heating is central gas with a prescriptive solar thermal system. All equipment does not exceed federal minimum requirements. The cooking and clothes drying is assumed to be in unit and electric. So from the electrification standpoint, the real focus of this analysis is on the water heating, with the exception of climate zones 1 and 16, where we're also looking at space heating. PV is now prescriptively in all of our multifamily buildings. For the 3-story, there's no change from the 2019 code, but we have a new requirement now for multifamily buildings 4 stories and greater. So that's included in our base case, as well as for 4 stories and greater, a prescriptive battery storage requirement. So these are the packages that we'll present today. We're also developing a few additional packages and welcome any feedback from you all on the call today after we present the results. Is there anything that's missing, any additional packages that would be useful for you in your process? So on the all-electric side, we have a prescriptive code minimum, and then layering on top of that additional PV beyond the minimum code requirements. And moving forward, we'll also be looking at an efficiency package for the all-electric. On mixed fuel, now this is, in most of the cases, this is really just gas for water heating is what we are talking about when we reference mixed fuel for this analysis. And we have an efficiency package and then a package that adds efficiency, PV beyond code minimum, and battery. And at this moment, we just have those for the 3-story, and we'll be working on those for the 5-story. So I want to just point out a few assumptions and kind of caveat some of the results that you'll see. The focus of this work has been on the dwelling units and the common area spaces. We have not evaluated the commercial spaces that are in the 5-story prototype. That is a part of the non-residential REACH code work and report. And so that work will provide the justification to jurisdictions to adopt a REACH code for those spaces. All of the utility costs are based on residential tariffs, today's residential tariffs, or at least from a couple of months ago. And as Misty pointed out, these results are preliminary. There's been a lot of development and movement in the multifamily realm in this code cycle. We are working with a beta version of the software that is actively being developed. We have the certified version from the Energy Commission, but we know that there are future changes that will occur between now and the implementation date of January of next year. We're also doing a little bit more research on central heat pump water heater strategies for the 2 prototypes, and I'll talk about that a little bit later. And lastly, utility costs are based on today's net energy metering 2.0. We know that that will be changing, but we don't know how that will be changing. So it's hard to estimate how those changes will impact this analysis. So we are using today's utility tariffs. All right, a little bit on the 2022 code. So this multifamily restructuring was a really big effort, and the intent was to simplify compliance and enforcement by taking all of the requirements for multifamily dwelling units and common area spaces and consolidating them into 3 multifamily specific chapters of the code. This aligned many of the requirements across low-rise and high-rise, not all of them. This alignment is ongoing, and there will be additional work in the 2025 code cycle to hopefully get to a full and complete alignment. But this is a really big step forward. And as part of that, all multifamily buildings are now evaluated in one software. So before, we had low-rise multifamily evaluated in CBEC Res and high-rise in CBEC Com. And this resulted in, I'm sure many of you on the call today have experienced projects where you got very different answers for a 3-story versus a 4-story building. So the assumptions and the modeling algorithms behind everything that goes into the dwelling unit and common area spaces is now combined. What was CBEC Com has now been rebranded as CBEC 2022, and it handles all multifamily and commercial. The California simulation engine was or is the residential engine behind CBEC Res. That has now been integrated into this new CBEC 2022. So that's where that alignment is between across all of the multifamily dwelling units and the common area spaces. So this was a really significant undertaking to to align multifamily in the code, but then also move it all into one software. And so that is why this software development is ongoing and a lot of work. And I mentioned before that heat pump space heating is now a prescriptive base case in almost all cases except climate zone 16 and 1. So that's our starting point. There is not a heat pump baseline for central water heating, but what we do have is when you model central heat pump water heaters, they are compared to a central heat pump water heater and not a gas system. And that was a change that's currently active in the 2019 code, but was made not too long ago. And it's an important update. And just one other change that I think is of interest to the folks here on the call today is some mandatory requirements that if you do install gas appliances within the dwelling units, you have to pre-wire them to accommodate future alterations to an electric appliance. So to reduce that cost when you do replace it with an electric appliance. And if you install a gas stove, you have to provide higher ventilation rates to remove the pollutants from the gas combustion. Okay, a little bit about costs and measure details and cost effectiveness. So Misty queued us up with the two methodologies that we use in our study. So we have our on-bill approach, which values savings based on utility impacts. And those generally are the investor-owned utility time of use rates. We also have results for Sacramento Municipal Utility District and the City of Palo Alto utilities. And escalation is factored in over the 30-year evaluation period based on CPUC and bonk assumptions through 2030. And then that second approach is time-dependent valuation, TDV, which is the Energy Commission's approach, cost-effectiveness metric for code development. And you'll see in our results slide that results are presented according to net present value and benefit to cost ratio. So the net present value is the present value of the benefit that you get from this change, this measure, et cetera, less the present value of the incremental cost over the lifetime. And the benefit to cost ratio is the ratio of those. So the present value of the benefit divided by the present value of the cost. An NPV of 0 or greater and a benefit to cost ratio of 1 or greater indicates something that is cost effective. So in the next few slides, I have a lot of detail and I won't get into all of it, but I wanted to include this since we will be sharing these slides for all of you to have. So I'll just try to point out some of the critical points that I'd like to send you home with. So the central water heating, which kind of is the big focus of the electrification analysis, really leveraged the 2022 casework that was done by TRC in the All-Electric Multifamily Compliance Pathway case report. So as part of that work, a system design was developed for all of the prototypes, a gas central water heater and a heat pump water heater, central heat pump water heater design was developed, as well as detailed costs. And so that's what our modeling is based off, and that's also what our costs are based off. So the 3-story is based on a stand-in system with 4 heat pump water heaters. The 5-story is based on 2 Colmac units. And these are total costs here per building. And then over on the right, we have incremental costs per unit. So after factoring in, we have first cost and replacement cost over our 30-year lifetime, we do end up with a higher incremental cost per unit for the 5-story than the 3-story. And we'll see how this plays out when we get to the results. The heat pump water heater system, actually on a per dwelling unit basis, is similar cost between the two prototypes. What is a big difference is the gas system on a per dwelling unit basis is much lower in the 5-story. A gas system is much easier to scale up in a larger building than a heat pump water heater system. Not that it's not technically feasible, but there's more complexities involved with it. On the space heating side, remember, this really only comes into play in our Climate Zone 1 and Climate Zone 16 results. So these costs were based on also some of the data provided in the All-Electric Multifamily Compliance Pathway Case Report, and as well some recent equipment research and labor cost research. So the thing to point out here is that we have, pretty substantial first and lifetime cost savings per dwelling unit, which has mostly to do with lower labor savings from not having to run gas to each dwelling unit, not having to vent the appliance in each dwelling unit. These gas infrastructure costs are applied as savings in our all-electric analysis. So we take into account the savings for not having to run gas infrastructure to the building. While in single-family buildings, this represents a pretty significant cost per building. It's not so significant for multifamily and commercial buildings because that cost is spread out over, many spaces, many systems. But these are the costs that we are including. It ends up being, in most cases, about $100 to $350 per dwelling unit. Gas infrastructure costs, of course, are highly variable, depend on the site, the project scope, utility territory, many other factors. There's a couple of different scenarios that we did take into account, or I guess there was a couple different conditions in our cases that we needed to take into account. And one was, there was a big difference between our Climate Zone 1 and 16 scenarios where we do have gas to the units. That means we have individual meters for all of those apartment units. And so the cost savings from eliminating that was pretty significant, much more than in the case where we just have gas water heating, central gas water heating. The costs up top here are what was used in our TDV cost effectiveness and represent the total cost, the total estimated cost for eliminating this gas infrastructure. The utilities do have gas extension rules that do specify there are some allowances or deductions that the builder contractors can take. We did apply that, which ended up being on the order of about $3,000 per building. So we did account for that in our on-bill calculations, which is meant to be reflective of the builder, the developer, and the costs that they would see. PV and battery systems are incorporated both in we have them in the base case, but then we also have packages where we're upgrading those. So the PV costs are based on LBNL's latest Tracking the Sun report and take into account inverter replacement and maintenance, which is the cost for cleaning the panels. Battery costs are from the REACH code report that the statewide team completed last year. And lastly, before we jump into the results, these are the costs and the efficiency measures that we used in the 3-story analysis that ended up being cost effective in one of the packages. We did evaluate a few other measures, but they were not determined to be cost effective in any of our cases, so they didn't get folded into the efficiency package. All right, let's take a look at the results. So here is the 3-story all-elective prescriptive code minimum case. And let me just introduce you to these tables a little bit. We have 16 climate zones. But we have more than 16 cases because we have some climate zones where there are multiple utilities that serve them. And so we've evaluated a few climate zones with different utility scenarios. Source energy compliance margin. So Misty introduced us to this new source energy metric. So this is representing the source energy savings, which is a greenhouse gas proxy for these packages. And then the efficiency TDV compliance margin. And then these colored columns are cost effectiveness. So the first two represent on bill, and these are per dwelling unit. And the last two are TDV. There's benefit to cost ratio and then net present value. And the green means cost effective. The red or pink means not cost effective. So what is this telling us? Well, we do have a cost effective outcome based on TDV in all of the climate zones. And based on bill, it's cost effective in about half of the climate zones. And it's not too far off from being cost effective in the climate zones where it's not. What we are seeing is that the first year utility costs do increase in almost all of the cases, but on a lifetime basis, which takes into account those escalation rates for utility rates, we do see a little bit of savings across the lifetime. And so that's driving a cost-effective result on bill in many of the climates. So now we add on PV. So this is the all-electric prescriptive code minimum, and we're increasing the PV system, the prescriptive PV system, to offset 90% of the electricity use. We now see that we're cost effective on bill and TDV in all of the cases. So adding PV does improve cost effectiveness quite a bit. Of course, this is based on NEM 2.0. We have done a little bit of sensitivity analysis looking at how potential changes to NEM might impact results, specifically we were doing this relative to single family buildings. And the margins here in this case are pretty large. If you look at this net present value column, many of them are over $10,000. That's over the 30-year lifetime. So while we can't predict what will happen with an updated NEM, it's likely that many of these scenarios might still be cost effective depending on where the change lands, but some of them might dip below the 1.0 benefit to cost ratio threshold. Okay, so now we're going to look at the 5-story all-electric prescriptive code minimum, and it is a little bit of a different story. The big difference here is the central heat pump water heater basis of design, which is a Colmax system. This is a common product for a building of this size. It comes in various capacities, so it can be scaled much more easily to different multifamily buildings, different commercial buildings even. It's not as efficient as the Sandin system, which is applied in the 3-story analysis. The Sandin system is very high efficiency, but it is pretty limited in its capacity. There's one system size, and that means that to be able to serve more dwelling units, a larger building, you need a lot of heat pump water heaters, and that takes up space. It also impacts the cost. So the Colmax is a reasonable design strategy for this building. And like I mentioned before, it's pretty similar. It's actually a little bit lower in terms of cost per dwelling unit for the 5-story than the Sandin is in the 3-story. But it has a higher incremental cost because that gas base case system just scales more economically for larger buildings. So one of the things we are still looking into is if there are other strategies that make sense, that still are feasible and reasonable for a project to design for this 5-story building, which might improve cost effectiveness. I also want to point out that our compliance isn't as good as in the 3-story. There's a couple of, this package is generally cost effective, right? I'm sorry, this package is generally code compliant across all cases, with the exception of climate zone 16 and 9. With 16, we will be looking at adding some efficiency measures. The issue in 16 is the colder temperatures, the greater reliance on electric resistance backup. Both for 16, we're converting both space heating and water heating. Okay, and so we're fairly confident that adding some efficiency measures will bring that into compliance and probably will improve cost effectiveness as well. In climate zone 9, it's a source energy deficit, and the magnitude is really small, and we want to look and see how that changes. The compliance margins change with the new software, but we're looking into it. We don't think it's a big deal in terms of being able to overcome that from a compliance standpoint. The good news is that when we add PV, we are cost effective, just like we saw in the 3-story. Adding PV, or rather increasing the PV capacity for the base case system, improves cost effectiveness substantially. So this is similarly increasing it to offset 90% of the electricity use. And it's now, this package is cost effective based on TDV in all cases. And it's on-bill cost effective in almost all cases. Adding some efficiency to those couple of cases where it's not cost effective probably would bring that over the edge. And lastly, for the 3-story, we have the mixed fuel packages. So the table on the left is just efficiency, so just adding some efficiency to the code minimum. The table on the right is efficiency, increasing that PV capacity and adding 100 kWh battery. These results for the efficiency alone, we did not, of the measures that we evaluated, we did not find any that were cost effective for those milder climates 2 through 8. So that's why you see an NA there and no results. But adding, in the other cases, adding efficiency is cost effective. We have efficiency TDV compliance margins of about 5% in most cases. And then adding the additional PV and the battery is cost effective based on at least one of the metrics in all climate zones. And in about maybe half of the climate zones, or a little bit less, it's cost effective based on both of the metrics. The efficiency compliance margin doesn't change, but we do see more source energy savings from the PV and the battery, and on average about a 10% savings in most of the climate zones. So just a couple summary slides before I hand it back to Misty to wrap us up here. We do see electrification of central water heating cost effective in some cases, but it's more challenging in others. And right now we're seeing that divide in the 3-story versus the 5-story. What we'd like to understand is if in fact for that 5-story there really isn't a better solution, a better design that gets us cost effectiveness. What is the limiting factor rather than just number of stories? Is there a more well-defined limiting factor that might be able to help us understand in what cases it does make sense to have all-electric reach code and in which cases it might not, or we need to add PV or efficiency to make it make sense. But all-electric buildings are generally compliant with the 2022 code. We did not have that throughout the 2019 code cycle, so that's a step forward. Adding PV improves on-bill cost effectiveness based on today's tariffs. And For jurisdictions that are looking at an all-electric preferred and want to have an option for mixed fuel, we do have package that battery PV efficiency package that achieves about 10% source energy savings and is cost effective. And next steps, as I've said before, we will be updating the results. We're still determining whether we update them right now to the certified version, or if we wait until the next version is released. We need to get a little more information from the software team on when that might be. Also looking into what other options there might be for heat pump water heaters central in larger multifamily buildings. And there's a couple of additional packages that we'll be evaluating, efficiency packages for the 5-story prototype and also for the all-electric packages. So with that, Misty, I'll hand it back to you.
All righty, thank you so much, Aaliyah. Before I summarize things, does anybody have any questions for Aaliyah? I know that was quite a bit of information. Go ahead, Kelly.
Yeah, thank you. That was terrific. Thank you for walking through that. I actually had 2 questions. Way back towards the beginning of the methodology discussion, you mentioned something about electric cooking being the baseline. Could you tell me more about it? Is that actually part of the prescriptive requirements?
It's not about it's not a part of the baseline code. So the code is, let's say, agnostic to what fuel choice is selected for cooking and clothes drying, but we selected that as the base case in our analysis because that is typical in multifamily buildings. It's not all multifamily buildings have electric in-unit cooking and clothes drying, but when they do have them in unit, it's more often electric than gas based on some data that's been collected.
Okay, thank you for that clarification. And then you did mention you're looking at alternative scenarios for the water heating. Were you going to look at all at individual heat pump water heaters per unit? I have actually seen that in practice that people are doing that.
We were not planning on it. At least for it might, we have seen that too in a building that is more similar to the 3-story. The 5-story, it gets just a lot more challenging. And while that has happened the past couple of years with projects that are trying to be all electric and find a strategy that worked with the existing software capabilities, where before they were really limited in being able to evaluate central heat pump water heaters. Now we've got much better software tools. We've heard that there's many challenges with those, such as finding space, the trade-off of space for individual closets, 1 per dwelling unit, and many things that while I think it would show to be cost effective, largely because you would take advantage of eliminating the costs for running a gas line for that water heater to every unit. We don't think it's really representative of what those projects would experience and the design strategies that they would select in the field. But if I'd be happy to talk with you more offline if you are seeing more of those. If you're seeing some of those, it'd be interesting to hear a little bit more detail on them.
Great, thank you.
Mm-hmm.
Okay, thank you. And Jean-Guillaume?
Good morning, can you hear me well?
Yeah, hi.
I have 2 little questions. First, with the higher buildings, do you run into not having enough roof area, especially facing south, to fulfill the PV requirements? And my other question was, utility rates, will you update those in real time?
So the first question is something we will be looking at for the report, and it might end up being a problem in buildings that are taller buildings that are in an urban environment where the footprint of their lot is really just the building. In a project where it's it's on a larger lot and you have parking structures perhaps to be able to accommodate PV systems, then it's a lot easier to be able to cite that additional PV. But there's are some calculations that we plan on doing for the report. On your second question about utility rate updates, so we do generally update our utility calculations about, roughly every 6 months, or if there's a big change in utility tariffs. So these results that we showed today are based on, I want to say May rates. I'm not sure if we will update them again before the report, because we do want to try and get that out for everyone. It might depend on if we see significant changes in utility rates between now and then.
Thank you.
Thanks, Leah. And Nilmini?
Yeah, hi, thanks. I kind of have follow-up questions to the previous questions. One was, what does 100% PV mean? I think I saw that in one of those. And then related to the rates, are you using, I might have missed this, are you using time of use rates? And also, for example, if not, or even if you are, there are several time of use rates or several residential rates. People who have PV often have EVs and then qualify for the time of use EV rates, and which are a lot lower, for example. So I was wondering about that. And then the final question was one of your conclusions. You said all electric buildings are now compliant with the 2022 code. That indicates they were not with the 2019 code. Can you sort of identify why not?
Sure. Let me know if I miss any questions. So,
sorry.
That's fine. Yes, we're using time of use rates in all cases, and we have conferred with the utilities to determine what is their standard or default rate that these buildings would be eligible for. We have not evaluated an alternative rate, such as the EV rate that not all the utilities have, and the eligibility for that is different. And so because we're not including EV in this analysis, we haven't evaluated that. One thing I will mention, though, is that we are evaluating care rates, and that will be included in the report, the impact of care rates versus standard rates. 100% PV or 90% PV references the offset of the estimated electricity use. So we looked at, the building is estimated to use X amount of kWh per year, and we size the PV system to offset 90% of that or 100% of that.
All right.
And I think your last question was about all electric building compliance in the 2019 code. So there's been a lot of development a lot of it has had to do with modeling of central heat pump water heating systems. And a couple years ago, we were very limited in what we could model. And not too long ago, we couldn't model central heat pump water heater systems. So, and there has also been some changes in how those systems, what they're being compared to, whether it's gas or electric. And so those software updates combined with the new metrics in the 2022 code, which the TDV was updated, and that impacts how electric systems perform relative to gas systems, and also this new source metric, which is a greenhouse gas proxy. Those two things really work together to encourage electrification.
Oh.
So that's a little bit of
shorter. Yeah, but that's great. Thank you. That's enough. I don't want to take more time from others. Thanks.
Okay, thank you. Okay, and Jay, you have a question? Oh, you're muted.
I should have put my hand down because Jean asked a question regarding the amount of room on the roof for solar, and so you already answered it. Thank you.
Awesome.
Sure.
Okay. Thank you. All righty. And Jeremy, you had a question?
Hey there. when thinking about adding PV to 90%, I think it's a great solution. It's kind of baked into the 2022 code, right? I mean, elements of that. And I think when they were designing the 2022 code, there was discussion around triggers for exemptions, right? So I think there's a height restriction exemption, and everybody knows the mechanical system takes a portion of the roof deck. There's different kind of aesthetics that people want on their roof deck. So I think that the conversation kind of lends to, for the 3 to 5 and even the 10-story models, what happens with community solar. I wasn't sure, did you guys bake in community solar into the calculations? Because it's substantially cheaper to install community solar, but it's got a different mechanism, and the community solar world is changing for the utilities. I think SMUD has a program and the other utilities don't, so I wasn't sure if we're thinking community solar for that, or keeping the solar on carports or in green space and other things.
Yeah, that's a good point, and we haven't evaluated that because, like you said, there are so few programs out there, and it's being developed. Maybe, Jeremy, let's talk about that more, how it might make sense to incorporate that into the report, because our thought was that, you know, we do need to think about exceptions, right? Like if we're saying, well, you can do all electric in these buildings with more PV cost effectively, there's probably going to be scenarios where adding that additional PV is prohibitive for space reasons. And so making sure that that's quantified in the report in some fashion. And so maybe we figure out how it makes sense to incorporate community solar in that as well.
I think there's going to be just for the folks from jurisdictions on the call, there's going to be a bit of a transition that might take 1 to 2 years for the new community solar programs to ramp up per direction from the CPUC. So I think, you know, as you think about implementing this REACH code, there's going to be a transition that might take some time for the rate side, community solar rates to kick in. There's also the multiple meter situation for mixed use in community solar. So just be sure to confer and communicate with your local utility as these programs transition. So when you educate builders, you can point them in the right direction so they don't, the jurisdiction doesn't have to be caught in the middle on the community solar discussion, because it is a great solution for the urban core and some of the suburban core. I think there'll probably be solutions for the garden style 2 to 3 story multifamily, but then you go up to 4 or 5 and above stories, then it becomes a bit more challenging for where to put the solar. And we found that on commercial feedback from during the 2022 proceeding. So thanks for answering the question.
Thanks, Jeremy.
All righty. Excellent. Bo?
Thanks. I have some ideas for additional all-electric scenarios to possibly include. So
Great.
One would be federally preempted efficient equipment for heat pump water heaters and heat pumps. Another would be adding solar thermal. A third one would be 100% PV instead of 90% for all electric. These are all for all electric scenarios. And then the last ones would be 3-story with battery or 5-story with extra battery.
Yeah. Okay, so thanks. That's great. Yeah. So on the first point, it'd be great to talk with you a little bit more about that, because the federal requirements for heat pump water heaters. So, you know, I think generally that would be kind of going to like a sanded system for the 5-story, which is, it's not federally preempted actually, but it is more efficient. And so I think what we'd like to understand is that if there is a reasonable design strategy for that in the 5-story, then let's at least evaluate it and look at the cost for that. The battery, yeah, we can definitely look at batteries in the 3-story. And we had considered whether we increase the battery size in the 5-story, and we hadn't evaluated it yet, but if we're combining that with additional PV, that might be something that makes sense as well. So yeah, those are good thoughts. Thanks.
Great, thanks.
Thank you. And Christine?
Thank you, Leah, for presenting the draft results. And I have just two quick questions. The first one is regarding rates. Do you recall for Palo Alto, we don't have time of use rates yet. So I'm curious to find out whether you are using the tier 1 residential or the tier 2 residential electric rates, because that could make a difference.
Okay, yeah, sorry, I misspoke earlier when I said all of the rates are time of use. That's right, that for the Palo Alto results, it's not time of use. I'll have to go back and check that for you, Christine. I'll follow up with you after this call. We did update your rates recently as well, but I'll have to go look and see which one we're using.
Thank you. And then my second question is for the 5-story prototype building. Do you know where the equipment for the COMAC central water heater will be located? I think it, depending on whether this is on a roof or in the basement of the building, I've never seen the system before, but I think it's actually quite sizable. So if it's on the roof, that take up more roof space. And I know that from talking to our buildings department, we're working on some pilot projects to replace like mixed fuel gas packs with rooftops, and there are some seismic concerns regarding putting big mechanical equipment on the rooftop. So just curious, like for the prototype, where this piece of equipment is located.
Yeah, it could. So I think both of those are options that have been looked at on the rooftop and in the garage. Ecotope up in the Pacific Northwest has been doing a lot of designs with central heat pump water heaters in multifamily buildings, and really likes the strategy of locating them in the garage. It does take a space trade-off. The design does need to incorporate that space in the garage, and it will take up some parking spaces, but in most cases they've been able to do it so it's not too many parking spaces. And then they also incorporate some interesting ventilation approaches to kind of increase, make sure that the performance of the systems are working well located in the garage. So I think these results stand for a system that could be designed and be incorporated into a parking garage or on the roof. Of course, on the roof, you brought up some concerns. There's also the trade-off with the PV on the roof. So when we look at that, the PV size requirement, both prescriptive and increasing that to offset more in the all-electric design, we'll be looking at that in combination with, well, if we have this equipment on the roof, does it make a difference if we locate it on the roof or in the garage?
Great.
Does that answer your question, Christine?
Yeah. Just a quick follow-up. How big are these COMAC? Like the footprint of these equipment?
I don't know off the top of my head. But we have spec sheets, so we can, when we follow up, we can look at that.
Thank you so much.
All righty, thank you. We don't have any more hands raised. I don't see any more questions, but are there any others out there? Anyone else have any more questions?
This is Missy. This is Jeremy again from SDG&E. I wanted to just comment. We've seen a lot of builders in San Diego County putting in mixed-use multifamily, 5 to 9, 10 stories. And what we've seen is there's a lot of design challenges and solutions. So, for example, for central heat pump systems, we've seen some builders, they put the storage tanks, some in the parking garage, some in mid building, so the plumbing runs are short. And on the battery side, for the same reason, we've seen the batteries in the garage and in certain areas. So there is a market transformation of design coming out of, for example, AIA, California, the Architects Association. There's a lot of folks that are getting very innovative. So there's this opportunity to kind of merge with the design world to design these buildings. We know there's some great solutions that have been produced in the Bay Area, some great case studies. If people do have questions on multifamily, we do have a memo that was created by MBI on multifamily designing of heat pump water heating systems, central and unitary. And then we also have some videos on the Energy Code ACE website on how do you design and how do you meet the code requirements for the current multifamily heat pump situations for water heating. So feel free to send me an email, jeremyreef@sdg&E. I can send those on to you folks. So you can send them out to your builders and designers and developers that have questions or challenges along the way.
Great. Thanks, Jeremy.
All righty. Any other questions for Aaliyah?
This is
Kelly.
Kelly. Yeah, I just wanted to layer on what Jeremy and others have said. The utilities have been testing these systems in particular at the San Ramon Applied Technology Services Laboratory to support the Energy Commission in delivering data on the laboratory testing performance of these systems in order to inform whether or not the software is accurately modeling them. So the Colmac and Sandin units, I would need to compare the spec sheets, but speaking without looking at the model numbers, I believe these are the models that were tested in the lab as well. So that's another way that we're looking at, okay, we're not just picking models off the shelf, but we're also looking at how do these perform in the lab and what was their expected configuration. We're also doing recirculation loss testing at the lab as well. So I know that's a bit in the weeds for today's talk, but I know there's questions out there about why these models and what configuration and how do you know that this is representative of what performance can be expected. So lab testing, in addition to evaluating all the case studies that are out there that have gone before and been pioneers of central systems, and in addition to hearing from the building community, that also goes into what we can expect and why we choose these units. Thank you.
Kelly, will there be a report produced from that analysis, from the studies?
No, not
No?
usually. Usually
Okay.
what happens is it's data, and that goes over to end users to say, here's how they performed. And the end user in this case is the developers of the software if the Energy Commission takes a look at it and decides it should go. So unfortunately, there's not exactly a report where cities could take a look and see that, but I can certainly find out what documents are shareable if anyone like Christine is interested, and that would not just be a pile of data. So
yeah.
Awesome. That would be a connection to me.
Yeah, I think that would be great. I think that folks might be interested in that, in addition to Christine, if there's any info that can be shared. Thank you. Okay, and Bruce, you have a question as well. Oh, you're muted. Hold on. I can't unmute you. There you go.
Okay. Two questions. The first is, what is the body of data that you'll be presenting at the end of this this conference? Because there's a lot of good stuff that you guys have talked about, and there was a comment from the last about that, but it'd be good to summarize some amount of this to do that if that's possible. And the second thing is that we know that in order to meet the goals of the state, we're going to need to get more EVs on the street, and by 2035 they're supposed to sell nothing but zero emissions vehicles, which means that the comments, we need to make sure that that's put into the total electrical balance package that goes out in regards to these multifamily buildings. And we're going to have to be smart about things in terms of current, limiting the amount of current that goes to particular things. I mean, there are a series of tools that allow for some of that proper use of current. So I'm curious to know when you're going to be incorporating more EV stuff, because that's another contributor to the electrical usage of the building, and we've got to manage it well. And we've got to make sure that all the new buildings have EV charging in them so that the people who live in multifamily buildings have the opportunity to charge at home.
You know, I can jump in, Aaliyah. This is Jeremy. On the EV side of things, there's a lot of things moving in the space. So the 2022 Cal Green update for EVs has a lot of increases in parking capacity mandated by the current 2022 Cal Green. So if you look that up, feel free to send me an email. I can send you some links to review. But one thing that's happening is the Building Standards Commission and HCD are mandated to look at the mid-cycle review and update, you know, even more. They're going to stair-step the amount of multifamily parking going into the buildings. And one of the things that they're looking at to kind of answer your question on multiple vehicles and load is there is an option for advanced load management systems, which is a technology that kind of triages charging. There's not a huge peak demand. There's a lot of solutions at the code level to definitely review. If jurisdictions want to go above and beyond those Cal Green requirements, we definitely endorse that. There are solutions in the space for that. There is a potential new mandate that's coming out of the state Senate right now. I can look up the Senate bill and put it in the
1482.
Yeah, so that could mandate that there is a 1-to-1 ratio of parking spaces for assigned parking spaces to multifamily, which would be great because that then answers the question. We did meet with KB Homes and some other builders on the new 225 panel requirement for residential and multifamily per the CEC's mandate, which is a pretty big jump from a 100 amp panel. They said that 225s can work for EVs to a degree, but if you're going to jump into multiple panel upgrades, to your point, the electrical engineering company designer would have to spend quite a bit of time just accommodating the EV capacity in some of these panels. So whether they're master meter panels that will, you'll be routing the EV charging through, or individual meters that go directly from the parking lot or parking garage to the electrical board at the unit. So that's why there's so many discussions on this. But I think we can update you individually if you have questions, because we're monitoring that legislation and other pieces of legislation around multifamily and equity solutions for EV charging for all. So I like your question.
Yeah, I wanted to raise the issue because there was a comment previously that said, you weren't dealing with EVs at this point. And I wasn't sure exactly where that ended. And I look at the total load of a building and I see that we're going to need to plan for EVs, and we need to make sure that there, as is in 1482, that every eligible parking spot has at least a level 2 low power ability to do that. And that was one of the criteria for that. So it's good to see that you guys are working on it, because it definitely has to be part of the building.
I would recommend looking up the CPUC's transportation electrification roadmap. There's the CPUC's transportation electrification roadmap. I'll put that link in the chat in a moment. But
Okay.
Basically, it's mandating that Cal Green looks at that question you're asking. So at the individual local ordinance level, you can look at those capacity concerns, but the state, through the CPUC and coordinating with the Building Standards Commission, HCD, and the CEC, has mandated they look at solutions for multifamily charging. So there is some leadership at the state level, but at the local level, feel free to kind of go above and beyond that at any given time. But I'll pause for Kelly's comment.
Just Bruce, I know that you're following this closely and have a lot of knowledge in this area. In terms of our analysis for cities, when we start to have more data and information that shows that the hope for the way the code will play out, and as cities start building buildings that perhaps will meet reach codes that reach beyond the 2022 standards, and we see that charging and EV uptake, then as we can collect data on that, because there isn't a lot of coordinated data throughout the state right now on how the loads are playing out in reality, then you will see that start to perhaps enter the analysis. We don't have a timeline where we say we can only do this once and that's it for a whole code cycle. So if we start to get good information that changes the way that we model, then I think we would start to incorporate it into our studies. And then once the information enters the code and there's more spaces as the baseline, then we have to include it in our analysis, just as we did with PV, and then in this code cycle with the addition of this small amount of battery and so on. So that's kind of how I'm viewing it in terms of this project. So the work right now, as Jeremy said, which you're already aware of, is getting it into the policy and expanding that. And then it's collecting data on the buildings that are slated to be built and making sure we accommodate it then. Aaliyah, Misty, did I say anything there that conflicts with your implementing and leadership of this work?
No, I think that sounds right. And the only thing I would add is that I don't see that if we were to incorporate it, I don't see that it would change the results that we have unless we were also looking at as part of a REACH code, a change to the EV requirements. But if we assumed some level of EVs in the base case, and as I understand it, that likely would be on a separate commercial meter and would not be metered under, at least in a larger building, under the residential rates. But people can correct me if I'm wrong on that. But my point is that I don't think our results would substantially change.
There are advocates who are strongly putting a position forward that it be connected directly to the tenant meter, and that tenant be able to reap the benefits of those EV rates and be in control of how they use that as an amenity. But that's to be determined. That's in the future. It's not in the code yet. So that's exactly right, Aaliyah. It's not there yet. That's not the norm. It may change in the future, but that would be our future analysis.
Are you guys looking at technologies for doing that? Because there are a set of power sharing devices that can help in terms of being able to connect things directly to meters. And then that raises a question that's beyond the scope of this, but we have to figure out how to address the existing buildings.
The utilities each have teams that are looking at those types of technologies, but the REACH code program is looking at what the policies would look like should cities start requiring them. And we would reach to those experts on those clean energy transportation teams, as well as in our own codes and standards program, those researching what those technologies might look like in terms of code language. But they're different groups than what you have on the call today. And I'll let Aaliyah address the other portion of the question.
Did you have another question, Bruce? Apologies if I missed it.
Oh, no, I just wanted to make sure that, that somewhere along the line, at some future point, you start to think about what we do about existing buildings, because it's a very tough challenge, but we need to do something about that. And, we can start to tackle it a little bit on as we get to buildings, but it's going to be something we need to figure out in the same way that we need to be able to retrofit buildings with heat pump water heaters and heat pump space heaters. So.
Yep, agreed.
We did have a program at SDG&E that just, I think, wrapped up, which was we put in electric vehicle charging infrastructure for multifamily units, I think 300 different projects mandated by the CPUC. And those went really, really well for existing multifamily buildings. One of the challenges we did find is that the upfront cost was very extensive to go into an existing building. So I think the key win is the new construction for multifamily, and the heavy lift will be existing buildings, to your point. And then also, I know that commissioners of the CEC have been looking at existing buildings as the next challenge for the code. So look to the 2025 code and 2028 code for opportunities. But if local jurisdictions can lead by example, that would definitely carry a lot of weight. Additionally, if you are interested in any of the CEC's, the Building Standards Commission's workshops on electric vehicle infrastructure, we can track those for you. Feel free to send myself or Kelly or Jay an email saying we want to participate, because your comments are very valuable at some of these public workshops on electric vehicle infrastructure for CalGreen. There's a lot of active industry folks, and if the jurisdictions show up, that'll definitely be awesome to get your feedback along the way.
Alrighty, thank you. I'm gonna, go ahead, Bruce, you get the last statement here, and then we got to cut off.
I just want to make sure that, I apologize. I just want to make sure that there were references to all the good stuff that you guys talked about somewhere that I can get them, because you mentioned studies at 300, units or whatever. I'm very interested in seeing what you guys did for that now that I'm trying to work through an example now. So
yeah, I'll send you an email on that.
Okay.
And in anywhere there's links in the chat, I will add a slide to the end of the presentation and capture all those links for you.
Thank you.
When we send them out. So it'll just be at the very end.
Thank you.
Awesome. Okay, great. Thank you very much. And sorry to cut you off. We have just about 10 minutes though, so we've got to kind of move on. This was great conversation. Thank you all for your questions and all the conversation here. A lot of great suggestions. And we're really, really happy to hear that you have some other ideas for us. And let me move on here to moving forward from the studies. So we gave you quite a bit of information in these studies, as we usually do, because it's statewide and there's a whole lot of stuff. And so, now that you have the results, kind of what's the next step? Where do we go from here? And so I'm going to show this process slide. Now, before we go forward, it's shown in a straight line, but we know it's not like that. We know that it goes in circles, it's iterative, it moves all around, and that you're balancing a lot of considerations as you go through this process. But just for ease of showing the basic process of developing an ordinance, we have it in a straight line. But at this point, you're probably somewhere here in the middle of the process where you've probably gotten goals, or that you've got a cap that is directing you, that has measures that you're pursuing, or you've gotten direction from council to explore the options. The technical information is now coming together, so we'll have at least some of those results. We have a good indication as to the direction and the general result from each package. And so you need to start developing a reach code to a proposed ordinance. And so getting ready for that formal process and starting to do the outreach and things like that. So we have identified a couple of different paths. There are, I'm sure, others, and there are many creative people out there thinking of many different ways to go about this. But so far, we have a few different paths that I'm going to run through. And you may have heard this before, so pardon my repetition if you have. But we've found about 4 distinctly different paths that you can take here. This is a bit of a busy table, but bear with me if you can for just a few minutes. I'll walk through each component. Essentially, as I said, there's about 4 different paths. The first one would be our traditional energy reach code, where you require some level of efficiency beyond the minimum compliance. That's generally something that's done through the energy code, has to be, and has to be cost effective. And basically the requirement would be all projects have to exceed the code. That's a pretty simple way of exceeding the code, and also preserves choice for people. Then the next step up here would be what we call electric preferred. And that would still be an energy code amendment. But in this case, you would only require that a mixed fuel building exceed the minimum code, and all electric buildings only have to meet. The idea here is that you would still preserve choice, but encourage that all electric design by making it a little bit easier than the mixed fuel. Okay. Third, there's electric only. And at this time, we've identified a couple of different ways you can accomplish that. One is a building code amendment through CalGreen, and the other is a municipal code amendment using the jurisdiction's, essentially police powers to maintain health and safety. There's effectively, they result in the same thing, which is that all new construction is electric. But they target different pieces of the code. So in the municipal code amendment, you're actually targeting the infrastructure. There's no new infrastructure, versus the building design. The whole design must be electric only. The municipal code amendment is not part of the building code, so it doesn't have to be renewed with the building code cycle. However, I understand that these ordinances are reviewed on an internal basis. And so you are likely to have an internal review at whatever cycle your jurisdiction looks at these kinds of things. But there's not an official renewal that has to happen each time the building code is updated. Okay, and kind of the most aggressive ordinance would be to require electric only and add efficiency. You can take either of the paths we just talked about, building code or municipal code. But you'd also have to go through the energy code to incorporate the efficiency component. And in that kind of a code, all new construction would be required to be electric and exceed the minimum code requirements. So they'd also have to be efficient electric. This has the biggest impact. It does have to be renewed, either whether you accomplish the all-electric piece through the building code or not. The efficiency piece would still need to be renewed. So there's several different paths you can take, and that's going to be something that varies by jurisdiction. It really depends on your city attorney, and how they feel about things, how they prefer to go about it. So that's something you'll have to work out internally with folks, with your internal stakeholders and external stakeholders to decide the best option there. I'm happy to talk with you guys about these anytime. And lastly, I mentioned this tool earlier, but we have a fairly sophisticated tool available that can help you take all the information from the study and actually start working towards an ordinance. This is the Cost Effectiveness Explorer. And essentially, the tool will pull all the data from all the different tables that Aaliyah showed in the report, plus all the different results tables that are in these reports, and it pulls all the data that you need and information that's specific to your jurisdiction into one place so that you can review just the results that apply to you. It will show if your jurisdiction spans 2 different or more climate zones. It'll show the results for each climate zone in your jurisdiction. And the Explorer, it actually is the place where we're housing the detailed results from these studies. The report that we issue will show more of the high-level results and the different packages which are cost-effective and under which metrics. There will be costs and things like that, but the actual detailed energy savings and all the calculations, those results will actually be available in the Explorer. And so you can go in there and play with those. You can actually, at this time, you can just see the results for new construction. We've got the 2022 single-family results included there. And so you can look at those, and you can actually develop a little bit of a citywide forecast with that. We have assumptions for the new construction rate, which you can go in and modify for your jurisdiction. If you are a data file, you really like to play with some of these things, we also have here right on the entry page, there's a link here where you can download a spreadsheet impact model. So if you're one of those people that likes to get behind all the assumptions and play with the data, this may be something that you're interested in. Lastly, we've also incorporated a new feature here, which you can access in this bottom right-hand corner. There's the little smiley face icon. And if you click on that, you can either send a question that can be answered in not exactly real time, but sometimes real time, but very quickly. Or you can schedule a 15-minute walkthrough of the tool. And so Jasmine Kraus will meet with you and walk you through the basics, answer any questions you might have, and help you get started if you're having any difficulties. So highly encourage you to do that if you're interested in a quick walkthrough and kind of an easy tutorial with a live person. You can do that with that icon, or you can also send an email to explorer@localenergycodes.com and get that scheduled. The development team is very busy working with the technical teams to incorporate the additional results as they become available. Like I said, we have the single-family preliminary results in the tool now. We are working on adding results for the ADU model, as well as the results for non-residential new construction will be next. We haven't added multifamily yet, but you can look at those results on a per home, per unit basis, as well as, like I said, citywide. Within the next couple weeks, we'll be releasing a new version of the tool that will also allow you to develop a new construction policy and save it and then compare that and share it with others. And so you can start looking at the different, at the impacts of different policy choices. So keep an eye on that. And you can also, just to let you know, you can sign up to get notices of new releases and things like that. Very easy on the tool. And highly encourage you to check it out. It's very, very helpful. It really gives you an easy way to look at the results and process them. So thank you very much. That pretty much does it for us today. We have, we're right on time here. We have 1 minute. So thank you all for all of your great comments and questions and for actually taking the time to attend with us. And special thanks to Aaliyah for a great presentation and all the hard work you've done to get there.
Yeah, thank you, Misty. A lot of people working on this. So I'll just echo thanks everyone for joining today. And if you have any follow-up questions, please reach out to any of us.
Please do. And we have our emails on the last slide here.